How are you doing? I'm Mohammed Hassan.
My name is Emmanuel Arsate.
I'm Bubakar Chusu.
And I'm Odette Bryant.
All right, today what we're going to do is kind of give you an understanding of what we had to do as far as our senior design project. It is Quick Park Smart Parking System. Here in this poster, what you'll see is we have a few design problems. And in our problem statement, we discuss what it is that we're trying to achieve. As the number of automobiles increase, and as the number of people on the street increase, we actually had to figure out a way to make sure that people can get to parking spaces easily and effectively. What we did is we enlisted Marty Cotis. He's one of the second largest owner of real estate development here in North Carolina. And he has problems with his parking when he's trying to develop his new buildings. So he wanted a system that he can use to alleviate some of the issues that he would have. The Quick Park Smart Parking System is designed to be functional in outdoor weather conditions, which we will test later. And also, it has to be an accurate system for the users. The target of our objective, or obeam, which is our name of our design team, is to develop a system that allows the users to locate parking spaces within an efficient manner. There are a few design criteria that we went through. One, the system must be able to handle high traffic data. The system must be able to withstand temperatures that will be outside in the elements. The system must accurately detect the parking lot spaces and have a very low error rate. The system also must calculate or provide the users the spots based on their search criteria. And that's something that we'll discuss later as we discuss the design architecture.
Okay, so for the design architecture, we have 4 blocks. The first block is what we call user handler, which is basically where the user is going to input his needs. And then also we have the GPS, which is going to locate his position. This information will be sent to the central control unit, which is a determination module. The second module is the space detector, which is basically where the sensors are located. So the sensors are going to sense the data and send the information wirelessly to the central control unit. The central control unit is nothing but a computer that is taking all the information, doing the arithmetic manipulation, and then send the information to our fourth module, which is a display module. So the display module is basically an Android app, which is displaying the spaces available and then the probability of getting one of those spaces. So you have a GUI that allows the user to choose the different parking spaces. And then if you have a preference, you can choose the preference and get the probability of getting that preference. So next we are going to discuss the design implementation of the project.
So for the design implementation, what we decided to do was basically choose some sonar sensors as part of our actual detection module. So it's a network of 8 sensors that we have set up right now, and it's basically composed of HCSR4 sonar sensors. They're hooked up to an Arduino microcontroller that does all the data processing to monitor the status of the parking spots. The next module is basically part of the determination module, which is a central control unit. The central control unit is just basically a laptop. So on the laptop we have 3 pieces of software that's running. One of those pieces of software is basically reading the serial port coming in from the Arduino microcontroller through a wireless transmission. So that's what that's doing right there. And then as far as the second program that is actually running, the second program, it's taking that information coming in from the Arduino microcontroller and uploading it to a database. And then finally the third program is basically checking to see the status of the user. So the user's making a request, it only provides, or it only calculates a probability for that particular user, or the user's making a request to a specific parking lot. So that's basically how the data gets processed from the central control unit up to the app. And then the app, in order to be able to display that information, it's got to be able to pull back information from the central control unit. And it also has to send information to the central control unit to be able to pull off the user's GPS location and calculate its distances and that sort of stuff through the app. And basically, that's basically how we decided to do our design implementation.
So in results, we were able to achieve our goal in creating a system that allows our users to locate a parking space in an efficient manner of time. We were using software that allows our users to interact with our smart parking system through the use of a mobile app. And our final project prototype included 8 spaces where we got our sensors to detect an object in the space and able to send that information to a database and also update our app to where our users can log in, choose a parking lot, and see the available parking spaces.
So as far for what we have done in conclusion is basically we were able to make a prototype of a kit park which can be improved by making it on real testing, making it on the parking space. So the discussion we will have is if there's any next project continuation, the group can take up this project and make it work on a real parking space. So there will be a lot of improvement that can be made on the project. As far as the box, put implementation in the box, and the what do you call this? Camera. There's 10, how to put it. There's 10 where you put the system itself in front of the parking space.
And that's where we're moving for the mechanism for retrieving the lot data based on the system that we designed is able to be upgraded. And that's the most important part of the design that we developed is that this sonar sensor detector can be replaced with a different type of detecting apparatus. So there are a lot of different ways we can actually detect using the same software that we already have in place. So the system is upgradable, which is a very key part to the way we designed our program. Thank you.
And the next part that we'll be doing is we're going to be demoing and testing out some of the test documents that we have put so far into our final product of the app. This is what the login screen looks like, and we had to create a login system in order to keep track of the user's distances in accordance to each other. And you simply just log in, and then basically this is the selection module. This is where we actually take the user's request into consideration, and if you wanted to, for debugging purposes, we have it pulling the user's GPS location with this button right here, but it automatically does it as well. So you just press show location and it'll show you your GPS coordinates. And then as far as you push this little drop down selector menu, and then right now we only have 2 parking lots available, McNair and Martina. The one we actually programmed it to work with as far as like the GPS coordinates is McNair. So if we press McNair, if you press McNair, it'll give you like a readout of basically the available spots. So right now it's telling us that all the parking spots should be available. And now we're going to do our test number 1.
Test number 1 checks the engineering requirement that the system must calculate the user's probability of finding a parking space and also give a delay before declaring that space to be available. The way this is to be done, the detection module should be connected to the central processor, which it is, which is our computer. The central processing unit must be running the software to read the serial connection, which it is doing currently. And then that data will be outputted to the Android application. This particular test, what we use is a color code to determine whether or not the probability of finding a space is likely. As you see green, that indicates that there is almost certain that you'll find the space.
So as there is an object on the actual parking spot on our app, it's going to display that there's there's an object there. So it's going to show a green dot signifying that it's actually an occupied parking spot. And if somebody else comes a little bit closer and other spots start getting filled up, then it's going to show different parking spots being full as well.
So do you need to refresh it manually or?
The app?
Yeah.
Yes, the way we have it set up, you do have to refresh it manually right now.
A pass for the test 1. Test 2 is actually similar to what we're just representing. Putting sensors in, putting objects in the sensors and having them detect and having that sent all the way through to the device. So this system is supposed to check that the database should be updated accurately and give a high percentage yield of not having an error, actually. The detection module, as far as the setup, should be connected to the central processing unit. The detection module should be turned on and the software should read from the serial connection of the detection module. And the central processing unit must have the internet connection to update the MySQL database on a remote server. And that's what we showcased here. As you can see here, the CoolTerm software, what it is currently doing is actually reading the serial port that's been wirelessly transmitted by way of the Arduino. And that particular information is updated into the database for use with the application.
So what is this binary notation that you have for the car? So does it actually recognize what car is in there? Or
Yeah, it gives representation on our screen as to what cars are available, or what car spaces are occupied, rather. So this first bit here, so we have an 8-bit system here. The first bit represents the parking space number 1, and it goes 1 through 8. So each bit is represented through the binary combination that we have there. In test 3, the engineering requirement, the system must provide available spot based on the user search criteria. A manual, as he showed you earlier, where the user actually selects the parking space. So the first thing we should do is connect the Android app to the central control unit and start the app running. The app should display the list of parking spots that are in the system. You should actually select a parking lot listed for the user to park. The Android app then should display all the information about the parking lot, such as locations, total number of spaces, and so forth. Here, this display shows 8 spaces, which our system has the capability of using. Right now, it shows that no cars are parked on the lot. The Android app should display an ordered list of 2 to 3 best parking spaces based on the user's parking preference. So if the user, what this system actually does, it actually shows the user where the spaces are occupied so they can use the other spaces that are open to them.